Okay, so for our third video for lesson 1, and we're just going to look at now some operations on complex numbers, operations on or with complex numbers. So when we talk operations, we're talking about starting to maneuver them. So adding them, subtracting them, multiplying, dividing, raising them to different powers, right? Just starting to work with complex numbers and seeing how they behave differently. And this is where things start to get really interesting. So far we've just been looking at really the idea and the history, some of the different a bit of language, but now we're going to start to operate on them. So really, it's similar, might I say, to the additive rules, the arithmetic rules, and the multiplication rules are similar, really, to say the work on surds might be. So if you were to ask to simplify, I don't know, maybe root 2 plus 3 plus the square root of 8 perhaps, and you'd have gone, oh yeah, right, well I better just perhaps simplify the square root of 8 to 2 root 2, and then I'd have put my root 2 and 2 root 2 together, and I'd have come up with 3 plus 3 root 2 or something like that. So I'd keep my real, my rational and my irrational pieces separate, and if I'd had a 2 plus 2 up here, plus 2, then I would have put my 3 and 2 together to get 5, and I'd have dealt with it in such a way. We're going to deal with complex numbers in this kind of way, and we'll just go straight to this example here actually, and look at how we can affect some arithmetic with some complex numbers. So you see here that we have complex numbers defined for a Z1, 4 minus 3i, Z2, negative 2 plus 5i. Okay, so Z1 minus Z2 will read like so: 4 minus 3i minus Z2, which is negative 2 plus 5i. So we're going to say that that's, well, putting our like terms together, I'd say that's 4 plus 2 minus 3i minus 5i. So we'd end up with 6 minus 8i, and there we have it. That's my result of finding the difference between Z1 and Z2. As you can see, very similar to our work on surds and just how we would expect these numbers behave. Complex numbers won't behave as we would necessarily expect them to in other fields, as in other fields of numbers that we've dealt with. For instance, with real numbers, we can take 2 and 3 and get 5. That's with rational numbers. With irrational numbers, that doesn't equal the square root of 5. So there are some adjustments to be made, just as we've had to make adjustments in other areas. But with addition, subtraction, multiplication, complex numbers will behave as you might expect. So in part B, 1/3 of Z1. So we're going to take 1/3 of Z1, which is 4 minus 3i, and we're going to add 2/5 of Z2, which is negative 2 plus 5i. All right, so running this through, 4/3 minus I minus 4/5, and then we've got, what do we got there, plus 2i. So putting our real and imaginary parts together, 4/3 minus 4/5, we're going to get, what are we going to get there, 20 minus 12 over 15 minus I plus 2i, and we're going to end up with plus I. So we end up with 8/15 as the real part, and just 1i as the unreal part. So this is the result of 1/3 times Z1 plus 2/5 times Z2. Here's my result of Z1 minus Z2. Okay, we should now be right to complete exercise 3F by doing question 3.